Hello students, welcome to EPG Pathshala. I am Dr. Rashida Kanchwala, Professor, Government PG College Mahu, Indore. Today I am going to talk about milk cookery from your paper of food science. Students, all of you know that milk is a liquid and various changes takes place in it while it is cooked. Today, after going through this module, you will get acquainted with the changes which take place in milk on heating and apply this information while making preparations with milk. You will also identify different methods by which curdling of milk takes place and apply this information while handling milk. You will also get through different ways of preserving taste, flavor and consistency of milk while cooking with milk. Dear students, different changes take place in milk when it is cooked. These changes can be classed into two categories as per agent and chemical affected. First changes are effect of heat on milk protein and fats, and second effect of various agents on milk protein which leads it to coagulate. Students, heat affects physical and chemical properties of milk, and these properties affect behavior of milk during its use in food preparation. Proteins that lowers the surface tension of milk get concentrated in the liquid air interface on the surface when milk is heated. When milk is heated in an open pan, a skin or scum forms on the surface of milk. This skin is rather thin and mobile, but it gradually becomes tough and tenacious. This skin contains coagulated albumin and globulin. When foods are cooked in milk, the milk not only forms readily, but the scum tends to hold the steam formed in heating the milk. It is because of this, milk boils over so readily. What is the first activity when milk comes to your home? Of course, all of you will answer that we boil it first. Boiling of milk, besides preserving it for a time enough, causes three changes in it. That is scum formation, scalding and scorching. Generally, milk boiling causes scum formation on the top, which we say malai, which gathers on the top of milk, and all of us cherish this malai after putting it in tea, coffee, or other sweets. What is this malai? This malai or scum is film of protein, and it is formed when milk is heated at a high temperature. This malai or scum entangles fat globules in it. The fat, as we know, that fat in milk is present in the form of emulsion. When heating is applied to milk, this emulsion breaks and fat, which is not soluble in water, comes on the top of the milk and gets entangled in this scum. This scum is quite tough, and if we remove a part of it, it develops on further heating. Application of heat causes scalding of milk. Scalding of milk is a process when milk is heated on a low flame. That is, the temperature of milk is not taken to boiling temperatures of 100 degrees centigrade. Scalding is performed at 85 degrees centigrade or slightly more. If a milk is kept in a thick bottomed pan and stirred continuously, it is scalded. That is, it is not boiled, or scum is not formed on its surface. Scalding is a activity which is preferred in some milk dishes where boiling over stops cooking of milk, while scalding continues to cook the milk or concentrate it to provide a typical taste. Besides use in cookery, scalding also kills potentially harmful bacteria in the milk, and it also destroys enzymes that keeps the milk from thickening in recipes. Dear students, all of you must have known that when you boil milk carelessly, that is, when you boil it on a high flame, it gets burnt, and this burning process is termed as scorching of milk. In a scorching process, milk proteins are stuck to the bottom of the pan, and milk sugar burns onto the pan. Due to these occurrences, an unpleasant flavor and color is imparted to the milk. This color and flavor becomes an integral part of the milk. You know that we don't like scorched milks or recipes made with it. Students, before proceeding to milk cookery, we must be acquainted with the reaction of milk which affects its quality in cookery. Freshly secreted milk is nearly neutral to litmus. It contains carbon dioxide. The amount of this gas in milk decreases during milking and subsequent handling of the milk, while the percentage of oxygen and nitrogen increases. Due to this reason, the titrable acidity of milk decreases for a time if it is exposed in the air. But there is no such result if milk is confined or covered. Students, when milk is heated at the boiling point or at temperatures above or near the boiling point, the titrable acidity at first decreases owing to the loss of carbon dioxide, and then it increases due to formation of acids from the constituents of milk, the chief of which is lactose, which produces lactic acid. Amount of lactic acid production depends upon the time and temperature of heating. A greater amount of acid being produced with a longer heating period or with a higher temperature. Milk cookery is a science of curdling and coagulating of milk. First of all, we come to the coagulation of milk. We know that milk is a liquid which contains proteins. Protein in milk are dispersed or colloidal form. Milk proteins are hydrophobic in nature, but they are made hydrophilic by the presence of different salts and charges. Any condition which disrupts this colloidal state or which disrupts hydrophilic property of milk causes curdling of milk. Main agents of curdling are acids and heat. In normal course, slightly basic pH of milk supports its colloidal state. If the pH turns to be acid, charge on casein micelles gets nullified and it becomes hydrophobic, that is, it curdles down. Similarly, heat turns lactose of milk into lactic acid. This lactic acid also does the same work which the addition of acids perform, that is, it curdles milk. Accompanying figure shows us major changes in protein during heating. We can see that casein, unheated casein micelles has got calcium phosphate within it. When it is heated, it starts to lose this calcium phosphate. Resultantly, molecules of submicelle, or we can say casein molecules, get freed in the whey protein, which gets adjoined to each other to form a curdle or curd. When milk is coagulated by heat, the major change in it is denaturation of its protein. Chief proteins of milk are lactalbumin, lactoglobulin, and casein. Lactalbumin of milk forms a flocculent precipitate when heated for 30 minutes. This precipitate can be seen in the utensil at its bottom when all the boiled milk is taken out. Second constituent of milk is casein. Generally, milk casein is not coagulated by ordinary heating temperature for short time. But if it is heated for 12 hours at 100 degrees centigrade or 1 hour at 135 degrees centigrade or 3 minutes at 155 degrees centigrade, it gets curdled down. The rate of coagulation of casein depends upon its concentration in the solution, that is milk, and the time and temperature of heating. As a result of heat coagulation, besides protein, fat particles of milk also aggregates. These aggregated fat particles forms nuclei on which separated casein submicelles gets deposited. If milk is homogenized, this coagulation process becomes faster due to higher amount of fat globules, and in unhomogenized milk, coagulation time and temperature may increase. Besides protein and fats, milk salts have also their role in coagulation or precipitation of milk proteins. Milk contains divalent and trivalent cations and anions. The chief divalent cations of milk are calcium and magnesium, and trivalent anions are phosphorus and citrate. They have marked effect upon stability of milk casein. The divalent and trivalent ions are more effective in precipitating casein, whereas monovalent cations sodium and potassium are less effective. These cations and anions are attached with the milk. The calcium of milk distributes itself between casein, citrate and phosphates chiefly, whereas the casein of milk is most stable with regard to the heat when it is in combination with the calcium. When the amount of calcium in milk decreases due to its replacement by citrates and phosphate, casein becomes less stable. That is, if the amount of citrates and phosphates increases in milk, a need is there to subsequently increase calcium to stabilize casein. If the amount of calcium is not increased, casein may precipitate. After getting through heat coagulation of milk, now we come to acid coagulation of milk. Curdling of milk can occur by any agent which changes its pH. It may be an acid or an enzyme which is produced by which produces acid in milk itself. Acids can be acetic acid, citric acid or any other acid which can bring forth such a change. Similarly, enzymes from microorganisms which may accidentally or incidentally be incorporated to cause such a change can bring forth curdling or coagulation of milk. The chief agents which creates acidity in milk are two. One is an enzyme, that is rennet, and one is an acid, that may be any type of acid. Now we come on heating of milk with different substances. Most commonly, milk is heated with the sugar. When milk is heated with the sugar, it reacts with its protein. When dextrose, lactose or levulose, that is our common sugar, milk sugar or invert sugar, is heated with the skim milk or freshly precipitated casein, a dark brown color is formed in the product. This dark brown color is due to formation of lactic acid and casein compound. As the temperature is raised, the dextrose and casein becomes firmly attached to each other, and most of the biourate action of milk is lost. Relatively high temperatures for a short times gives only slight development of brown color when milk is heated with the sugar. Although it is almost impossible to retain natural color of fresh milk when it is heated with sugar. We can see this in condensed milk and condensed milk product. Students, after going through browning of milk when it is boiled with sugar, let me come to other type of milk browning, that is Maillard reaction. Maillard reaction is a non-enzymatic glycation of milk in which an amino group and a carbonyl group is added by a complex reaction which takes place during food processing and storage. In milk, lactose of milk reacts with casein and forms Maillard reaction, which results in the formation of melanosides or browning compounds. The Maillard reaction decreases bioavailability, solubility, forming properties emulsifying properties and heating stability of milk proteins. Formation of flavor compounds and browning compounds is caused as the consequence of Maillard reaction between glucose and milk proteins. As for the effect of Maillard reaction on the bioavailability of protein, various studies have performed and they have designated that this reaction increases lysine loss from protein, and the increase in loss is increased as the severity of heat treatment increases, and the modified lysine cannot be available as a nutrient anymore. We have sufficiently discussed outcomes of milk heating either alone or with other substances. Now we come to second part of milk cookery or second part of casein aggregation, that is Rennet coagulation. Milk may be coagulated by the addition of rennet, which is an extract of lining of stomach of calves, and rennet is a rich source of enzyme renin. As we know that renin is a milk hydrolytic enzyme which hydrolyzes milk proteins, and this hydrolysis brings about denaturation of milk protein and its resultant precipitation. Renin also reduces charge of calcium caseinate micelle, resultantly a reduced stability of casein in milk, and precipitation of milk is occurred. Because renin is an enzyme, and as we know that enzymes are very specific proteins which are affected by temperature, pH and other concerns. Similarly, rennet coagulation is also affected by many factors. Chief of them are temperature of for renin action, heating the milk before the addition of renin, hydrogen ion concentration of the milk, concentration of casein, calcium and phosphate ion in the milk, and other factors. As for temperature, renin provides best result at the temperature ranges of 40 to 42 degree centigrade. At these temperatures, it produces soft curds. Below these temperatures, the curds are very soft, and above these temperatures, the curds are tough and stringy. If renin is applied to pre-boiled milk, the rate of coagulation is retarded and much softer, more flocculent curd is obtained. Similar results are also shown by pasteurization of milk, which affects type of curd formed by the milk. The optimum hydrogen ion concentration of renin activity is between 5.99 and 6.40 pH. pHs above and below this range also affects its activity. If milk is diluted before casein addition, the clot formation is incomplete and delayed. Addition of calcium chloride to diluted milk, however, restores clotting properties of milk. Students, we have seen the action of rennet on milk. Somewhat similar action can be produced with addition of acid to milk because the casein of milk is least soluble at its isoelectric point, that is a pH of 4.6, and as we know the milk is nearly neutral. If we add any acid to it to bring its pH up to 4.6, casein gets precipitated with the formation of casein salts. The chief of them are casein chloride or casein lactate. Students, now we come to the chief concerns, that is cooking with milk. When we cook different substances with milk or milk alone, four happenings are to be handled. These happenings are curdling, boiling over, skin formation, and scorching. Before proceeding into their details, we must keep two laws of milk cooking in our mind. That is, use low heat and stir it constantly. Let we come to the first concern, that is curdling of milk. When we use milk with acidic substances like tomatoes, when tomato soup is to be made, or any substance, any other substance, if it curdles or separates into clump, the taste of the recipe gets destroyed. To avoid curdling or clumping of milk, we must have to use fresh milk because fresh milk has got neutral pH while aged milk has slightly acidic pH which easily curdles out. Second thing we have to follow is to thicken it with some starch. Thickening of milk with starch prevents its curdling. Second concern with cooking with milk is avoiding scum formation. Scum is unwanted in many of the milk recipes. It also stops milk cooking and it calls for greater handling of milk. If we want to avoid scum in the milk, we must stir it while it is being heated and use covered containers so can air pressure can be reduced. The third concern with milk cookery is prevention of scorching of milk. As we have discussed that burnt flavor in milk products is unwanted. It reduces its acceptability. So to prevent scorching, first thing we have to do is to rinse the pan with cold water before adding and heating the milk. Keeping temperatures low with continuous stirring and heating the milk and double boiler also avoids scorching. When milk is cooked in microwaves, it should always be cooked in a heat-proof glass container to avoid scorching. Students, now you must have been acquainted with the changes that occur in milk on cookery. And we can sum up that cooking temperatures affect behavior of milk proteins and sugar. Use of low heat for prolonged times coagulates milk protein and forms various products. Use of acid also coagulates it. Use of proper heat, stirring and addition of proper salts is necessary to milk to savor milk recipes. Thank you.